Hello, everyone. Hope you're doing well. So, the topic for today is neural networks in gaming industry. But before jumping into the topic, let's see the agenda for the day. So, we'll start with introduction, its role in gaming industry, neural networks role in gaming industry. Then we'll see a case study and a live demo. So, starting with the introduction to the neural networks before jumping into gaming industry. Although we have covered this in the class, pretty much covered this in the class, but still I would like to cover a few points here. So neural networks are pretty much inspired by the human's brain structure and how we function, how we process the information that we receive, and and they're used to make decisions and recognize patterns and predict the output based on the data that's given. So you can see a small animation here, which where we give an input and the neural network predicts it as a dog. So that's just a simple illustration of how neural networks work. So it has a couple of components. The main components out of them are the nodes. Nodes are the basic units of computation, which are like analogous to neurons in our brains. So that's why they're also known as neurons, nodes. And each neuron receives input, it has to process it, and it has to generate an output. Second one is the layers. We have three layers: input, hidden, and output. Each of them has their own task, as we know. Sorry. So yeah, input could be the can be considered as the initial layer of a neural network, and then there are hidden layers which processes the input data with the weights and biases and activation function and all of that we'll see in the later stages. So weights and biases. So these are the parameters to the network. Weights control the strength of the connection between the neurons, and so biases allow shifting or transforming the activation function to like to fit the data in a better way. Now, the activation function is a mathematical function applied to the neuron's input to introduce non-linearities so that the data is not way out of the scale and we can fit the data between certain desired limits, which which in turn allows the network to learn complex patterns and predict the correct outcome. Now, let's move ahead with the neural networks in gaming industry. Neural networks in gaming industry has like in the past few years revolutionized the game design, development, and the overall player experience, we could say, because there was a huge boom in the gaming industry in the last couple of years, and we have seen a variety of games which are using artificial intelligence and machine learning, neural networks, deep learning to enhance the user experience and give something new to the user, like to increase the market share or whatever maybe. So here are a couple of key areas where the neural networks can be applied and which are actually being applied in the current gaming industry. We won't touch down on all of these points, but I will just give you an overview of a couple of them, and then we'll see a case study and a demo on two of these. So the NPCs, the non-player characters, these can be considered as the bots in a game. They are usually called bots. And the neural networks enable NPCs to learn and adapt their behavior based on player actions. So if I'm playing a game and let's just consider I'm a pro at it. And so the bots inside the game will learn from my actions, my key movements, my uh, aim, and a lot of other stuff, or whatever the game may be about, and which leads to a more realistic and unpredictable player experience. It also makes the game quite challenging and like it can evolve strategies and respond to different gameplays. So, like It helps to improve the engagement of the user with the game and attract the user audience. Now, second one is procedural content generation. This is majorly used for the game development process, which like it helps to generate the content on the fly. Meaning, uh, can be like if suppose we have a complex game which has a forest, say for example. So we don't need to go and add each of the tree inside the game to create a whole forest. This procedural content generation we just need to tag that this area is a forest and it will create a forest on runtime. This heavily reduces the game development time and it also creates unique and varied experiences for the user. Third one is the game testing and quality assurance. So yeah, using neural networks, we can simulate human players and like a, a testing in a testing environment. We can introduce an AI agent which can act like a human player and complete all the levels of the game, which which helps in finding bugs very easily and it helps in the overall development life cycle of the game and helps in faster releases. So this kind of game testing is pretty essential for all of the games, I could say. First person, third person, any of the game. Uh, we could introduce neural networks to complete the game in a certain, like, we could give a time specification that you need to complete this game in certain amount of time, and which could lead to like more inputs from the user, like even the bot can generate inputs like how the game how what the difficulty of the game is and what difficulties can a user may find while he's playing that game. So yeah, that's what about. So we will see a demo of the game testing and quality assurance in the coming slides, which like I had developed a long time ago. Yeah. So moving forward, these are just the same thing again and again: personalization and player experience enhancement, which again comes under NPC behavior because it's more or less related to the experience of the user. And realistic graphics and animation again under PCG, voice recognition and natural language processing, strategy and game AI development, and a lot of there are a lot of more areas where neural networks can be applied in the gaming industry. Now let's look at a case study which used the NPC non-player characters, also called as bots in that game. So Counter-Strike Global Offensive is one of very popular games amongst all the esports players. So what this case study did was uh, it trained the bots with a two-stage mechanism, and so the main concept of the case study was behavioral cloning. Behavioral cloning is a very widely used concept in robots. Also, like a very popular robot you might be knowing called Sophia. He also uses behavioral cloning as the core concept of the human-like behavior. And the two-stage mechanism or the methodology was combining your gameplay scraped out of the internet, maybe like video recordings or streams or something like that, and uh, expert demonstrations provided by highly skilled human players. So on the right, you can see there are a few gameplays of experts which are being used as the inputs, and they used like around 6 million parameters to this neural network, and the study was like they had very good results. You can even find this is an open source study. You can find the link to the GitHub in my references as well if you want to go and have a look, maybe. So yeah, moving forward, let's see. So before jumping right into the demo, I would like to give a bit of a background. I hope everyone might have played the Flappy Bird game that we used to play in the childhood. There's a bird, and you have to cross that bird through the pipes. Yeah, so this was developed by me with the help of a couple of tutors around 4 to 5 years ago. This uses Python as the base language, and the libraries that we use here are Pygame and Neat. So Pygame is used to generate the game content, obviously, and Neat Python is the library that does the necessary calculations for our neural networks. So NEAT stands for Neuroevolution of Augmenting Topologies, which is inspired by natural selection. So natural selection is a process of uh, generations continually learning and getting better and better and better until eventually they can get as good as they can. So well, let's have a look at the demo. Sorry, I should have it just right here. Yeah. So I will start the demo and then explain it to you line by line how it works. So come up in a while. Yeah. So let's start with the first and the foremost essential thing, my layers. The input to my neural network. Each bird represents a neural network. The input to my neural network is the position of the bird on the screen. Say this, if you can see my pointer, this is my 00. So say my bird is here. So probably if say it's on 500. So the y-axis position of the bird, the distance of the bird from the top pipe, and the distance of the bird from the bottom pipe. These are the three inputs to my neural network. Next, the output. The output of the neural network is that the bird should jump or not. And that is calculated by the connections and weights. Now, how is the weight calculated? There are a lot of mathematics going behind. I'll share all the specifics in my repository. I'll share the repository with all of you guys. You can have a look. So, but the main point I would like to touch here is the activation function I'm using here. It's a tan H. I had a lot of options called like maybe sigmoid or relu or lot many as we name. But what tanh does is it scales the value from -1 to +1 to let me know. So after all, everything is just a set of if-else statements. So my output is designed in such a way that if the value of the activation function is greater than 0.5, the bird will make a jump, or else it won't. That's simplest thing, like simple calculation. But on the back end, there's a lot more to it, and how the weights are calculated. So each one is calculated by multiplying the y-axis of the bird to its weight to the output. Next neuron, sorry, the top pipe. It's multiplied by its weight, and the addition of all of those, and multiplied by a bias. Now, how are these weights and biases calculated? Like, how do we know what are the weights and biases from the input? So actually, we don't. If I just rerun this application, you see we are generating 50 birds on the first generation. So I have a good CPU. That's why it's not generating a lot of generations. But you can see here, it went to the second generation. Now the first 50 birds, they don't know anything. They are a set of randomly generated weights and biases, and the population size can be changed from the parameters, but the concept here is each bird is given a fitness value. So fitness value depends on how far the bird got into the game, which is calculated by the score over here. If you can see, sorry, the score. The score determines the fitness value of a bird. So in one generation, we select the top three birds with the highest fitness. If I move this a bit here, you can see the fitness score, the adjusted fitness size, the initial size was 50 for the first generation, and the fitness score was 45.6, which is again like calculated. It's not actually the score, but it's calculated using some parameters, but with the last score of the bird with the highest fitness value. And then the top birds from that population is the fitness values of the top birds from that population is passed on to the next generation, which makes this a feed forward neural network. And uh, so the next generation is populated with again 50 birds, which has some values, some weights, and some biases from the previous generation. That's that's what like that's the core concept of this project. Which so this was used for testing this game, and if the bird could like finish the whole game in a go. When we started developing this application, we had to wait for 14 to 15 generations for the bird to get to its correct fitness value and to complete go on in the game in an infinite loop. But now, since the processors have advanced and the library as well, so it can learn faster and in a much more effective way. So this is a basic code. I have attached my GitHub link in the presentation as well, and I will add it to the video description also. All you need to do is open the requirements.txt, install these dependencies, and if you want to check the configuration of the feed forward network, you can go here. You can increase the population size. You can decrease the threshold, or you can you can change the activation functions over here. Whatever you want to play with, and then just run the command python flappybird.py, and you should be good to go. Jumping back to my presentation, that was it for the day. These are a couple of references you can see. Uh, sorry, this is the GitHub link for the case study that we saw on Counter Strike, and this is the here is the GitHub link for my demo. So that's it for the day, guys. Thank you so much for coming here, and feel free to reach out if you have any questions. See ya.